Hello everyone. Today I'm going to do a quick video on when to use sine law or cosine law. So let's get right into it. What is sine law? Let me just write it up. It's sine capital A over lowercase a equals sine capital B over lowercase b equals sine capital C over lowercase c. That's kind of what you'll see most often if you're to Google sine law. Here, the little letters, the lowercase letters, they are side lengths of a triangle. And the uppercase letters are angles. That's kind of the big difference. And we'll get into kind of why there's matching letters there in just a second. And what is cosine law? Well, there's really just one cosine law, but it's written differently. If you Google it, you'll see more than one formula. But essentially, it's a squared equals b squared plus c squared minus 2a or 2bc times cos of angle big A. That's cosine law. I'll write out the other versions, but these are all essentially the same thing. B squared equals a squared plus c squared minus 2ac cos b, and c squared equals a squared plus b squared minus 2ab times cos c. You can probably see a pattern here. Whatever side length we're looking for, A, there's always going to be big angle A on the other side. What else? If you are looking for a side length, the other two side lengths have to be the only side lengths on the other side of the formula, so it wouldn't make sense if we had like A on this side because we're looking for A. Here we're looking for B, so there's only A's and C's, etc. Let me just draw a triangle so all this kind of makes sense. For sine and cosine law, you use non-right angle triangles. So what that means is, there's no right angle. So non-right angle. Angle big A, big angle B, and angle capital C. The way you label this triangle is angle big A is going to be on opposite of side length little a. So you could draw a circle around these. They're a pair of a side length little a and big angle A, or angle big A, I should say, capital A. Same with big C and little c. That's a pair of a side length and an angle. And big B and little b. Now these letters are totally arbitrary. You don't even have to label if you get good at this eventually. You could use any letter you want. But the key here is you have angles that are opposite side lengths. I will actually draw this in for everybody so they can see. I should use a different color for that one. And this color. So you can see there are sets of angles and side lengths. That's really important. So when do you use sine law? You use sine law when you are given a pair, that's all I'll say, a matching pair of an angle and a side length. So use sine law when you are given a matching pair or a pair of matching side lengths and angles. There definitely actually is a better way to say this mathematically, but I like to think of it intuitively. So I find that helps more people more often, at least to begin with. So if you're given little a and big A, you're going to use sine law. Let's do an example. I'll show you what I mean. So here, take a triangle that looks something like this. Mhm. Let's say you have triangle. Give me a second to draw this out here. It's not a right angle triangle, clearly. Okay, that doesn't want to draw. My bad. Maybe I'll have to do this. There we go. Let's say you're given a triangle that looks like this. 124.0 meters is that bottom side length. 68.4 meters is that side length. 136 degrees is this angle. And let's say we need to find, keep it consistent, call this B. Let me draw a nicer B for you all there. Okay, well, first thing to check for, like I said, when do you use sine law? When you're given a pair of matching side lengths and angles. So here, we have an angle, and we have its opposite side length. We have a pair. We're good to go. We can use sine law. So use sine law. That's all you need to check for. I'll show you how to use sine law in another video, but that's how you know. So we have a pair, use sine law. Next thing, you can also use sine law if you can make a pair of matching side lengths and angles. I'll show you what I mean. Let's say just a very similar looking triangle. Let's do almost the exact same. Might as well make it look a little different, I guess. A little less wide. Let's say we have a couple angles inside this triangle. 21 degrees and 18.7 centimeters. And let's say they want to find, I don't know. What do y'all think? Find this angle. Call it B. We want that. Well, at first glance, it doesn't look like we have a pair of matching side lengths and angles. But if you remember, all interior angles of a triangle add up to 180 degrees. So to make our pair, then we can use sine law. To make our pair, you go 180 degrees minus 35 degrees minus 21 degrees. That's going to be, wow, here we see my mental math, 124 degrees. That's going to be this angle. Well, look at that. Now we have a pair. Now we have a pair of matching side lengths and angles. Use sine law. Good to go. Hopefully that makes sense. I'm almost done. I promise. Bear with me. When do you use cosine law? Let's write that down. Use cosine law when, well, guess what? It's the opposite. When you don't have a pair. Again, there's better ways to say this mathematically, but I'm trying to teach it so you can understand exactly what to do and just go from there. Use cosine law when you don't have a pair of matching side lengths and angles. There's a couple situations where this might happen. Let's do another example. Example 3. You could have a triangle that looks at, it's a pretty classic example of cosine law here. Let's write it out here. You could have a triangle that looks like this. 7.5 centimeters, 11.2 centimeters. And they could be asking for, It could be asking for anything. They could be asking for these angles on the outside. But they could also be asking for this side length right here. Let's say they're asking for B up here. Well, you couldn't use Pythagorean theorem because this is not a right angle triangle. A lot of people make that mistake. They'll go, oh, B squared is A squared minus C squared. Well, not really true. Or, whatever Pythagorean theorem is. This isn't a right angle triangle. We can't actually do that. So there's no pair. We're not given a pair. We can't find a pair. So there's no pair. So what are we going to use? Use cosine law. That's it. That's all you need to know. I'll show you how to use cosine law in a different video. Last example. Another situation where you could use cosine law. Let's just pretend you're given nothing but side lengths, which can happen sometimes, and you need to find some angles. Well, let's say we got 5 centimeters, 10 centimeters, and 8 centimeters. Let's say we needed to find C up here. Well, we don't have a pair of matching angles in triangles, right? There's no opposite angle to this. Nothing. No opposite angle to this. And, obviously we're looking for C, so we don't know that angle either. So no pair. Use cosine law. That's all that really goes into this. So in conclusion, if you have a pair of angles, an angle and matching side length, well, you have a pair, check mark, sine law. Use sine law. No pair of matching angles and side lengths, and you can't make one. Well, in that situation, we are going to use cosine law. That's all you need to know. Hopefully this helps. If you made it this far, thanks for watching. And yeah, hope this helps. Take care.